Good evening. Am I audible to you? Good evening, students, and welcome to Unacademy. Good evening, and welcome to Unacademy's live YouTube classes. And I am Rashmi MR, welcoming you all to this live session. Before we start today, we are continuing from last class that we started studying alcohols, phenols, and ethers. We have finished studying alcohols, phenols, preparations, and physical properties. We started with the properties or chemical reactions of alcohols. But today we are continuing it. Okay. But before I start, let me tell you something about now what is Unacademy Plus class is all about. See, if you want to have a comprehensive batch, physics, chemistry, mathematics, or physics, chemistry, mathematics, biology, or physics, chemistry, biology. If you want to have a comprehensive batch where each subject of which you are going to write competitive exam, if you want to study, okay, with the complete syllabus preparation, then you have to subscribe to Unacademy Plus classes. Okay, you can subscribe for 12 months or 6 months, even for a trial period of 1 month. Okay, now if you go for a 12-month period, okay, subscription, you have to pay 12,375 rupees. That amounts to only 1,031 rupees per month. Or if you're going for a 6-month plan, then you have to pay 10,125 rupees, where that amounts to 1,688 rupees per month. Or you can even go for a trial period of 1 month by paying 2,250 rupees. So you get top content, premium content in affordable price. You have well-structured live classes, dedicated live doubt clearing sessions, quizzes, test series, daily practice problems, full-length mock test, which will all help you in self-analysis. And best of it, students, with a single subscription, you have unlimited access to Unacademy library and Unacademy classes, in Unacademy Plus classes, all the classes in a day, which will be telecasted. You can go and attend all the recorded classes. You can access, you can learn, and you can have an all-round preparation. Best of all, guys, if you use my referral code Rashmi 2020, if you use this code, you don't even have to pay this much, because you will get 10% discount. 10% discount is available. Okay, if you use my referral code Rashmi 2020. Okay, so use my code to get full benefit. Okay, yes, that is about Unacademy Plus subscription. Okay, let's go to the class, today's class. See, this I have already started. Okay, so you have any doubt, any questions, any queries, you can put it in your chat box. Okay, yes, Avril, good evening and welcome to Unacademy. Yes. Now, dehydration, I have already told, introduction has given. What is dehydration? Dehydration. You're removing water molecule from alcohol. You're removing water molecule from alcohol. Carbon to which OH is attached is called as alpha carbon, or carbon number 1 sometimes, or alpha carbon. And the carbon next to it is called as beta carbon. So, alpha carbon will lose OH, beta carbon will lose H. Between this alpha and beta carbon, double bond appears. So, when alcohol is dehydrated, the product is alkene. Okay, and the dehydrating agent is acids. Okay, acid dehydrating agent. If it is the primary alcohol we're using, and the dehydrating agent is sulfuric acid, concentrated sulfuric acid, temperature is 443 Kelvin. Okay, if you're using primary alcohol, depending upon which class of alcohol you have, reaction condition can be changed. Okay, so if it is primary alcohol, drastic conditions required. So you have to use strongest dehydrating agent, that is concentrated sulfuric acid at 443 Kelvin. Primary alcohol, that is ethanol, becomes ethene. Okay, dehydration at 443 Kelvin temperature by sulfuric acid, concentrated sulfuric acid, which is a dehydrating agent. Is this clear? So you will get primary alcohol will give you alkene. Okay, primary alcohol will give you alkene if it is dehydrated using concentrated sulfuric acid at 443 Kelvin. So this is the reaction condition. Concentrated sulfuric acid and 443 Kelvin. Primary alcohol becomes alkene. And from this reaction, you have to learn mechanism. It's a 3-step mechanism. 3-step mechanism. Did you understand this? Did you understand dehydration? If you're using primary alcohol, drastic condition is required. What is the drastic condition? Strongest dehydrating agent you have to use, that is concentrated sulfuric acid. Okay, at 443 Kelvin temperature. These are the two conditions. So primary alcohol becomes alkene. Okay, alkene, dehydration, water molecule is removed from alpha beta carbon. Okay, A mechanism, three-step mechanism. We are learning mechanism of conversion of ethanol to ethene. Ethanol is dehydrated to ethene. Okay, ethanol to ethene. It's a three-step mechanism, and the first step is formation of protonated alcohol. Okay, formation of protonated alcohol. The acid present will release H plus ion, and oxygen of alcohol has two lone pairs of electrons. So it is electron rich. Oxygen is electron rich. It has two lone pairs of electron. So the one lone pair of electron, okay, acts like a nucleophile and this takes up H plus. H plus is attracted towards oxygen because it has two lone pair of electrons. Okay, so one pair of lone pair of electron is used to take up or form bond with the proton. Okay, so let's say this is the proton which is bond is formed. So one electron of oxygen is still with the oxygen, but the second electron is lost to hydrogen. One electron is lost to hydrogen during the bond formation. See, these two electrons are now like this. So one electron is with hydrogen, only one electron is oxygen. Oxygen lost one electron, that is why oxygen carries plus charge. When oxygen is carrying plus charge, oxygen carrying plus charge is called as oxonium ion and ethyl oxonium ion. Since if you have taken ethanol, which is undergoing protonation, the compound formed is called a product called is ethyl oxonium ion, or it's just called as protonated alcohol. So alcohol gets protonated. You are adding proton to alcohol. So you get protonated alcohol as the product. Okay. So ethanol takes up H plus proton to give you protonated alcohol. Since it is ethanol, the protonated alcohol is called as ethyl. This is ethyl oxonium ion. Ethyl oxonium ion. Okay, that is the first step. So the product of first step is protonated alcohol. Take protonated alcohol in the second step. From protonated alcohol, look at the protonated alcohol. The between carbon and oxygen there is a bond, and oxygen is carrying plus charge. Between carbon and oxygen, which is more electronegative? Obviously oxygen, is it not? Oxygen is more electronegative. Correct? Oxygen cannot be positive charge when it is bonded to carbon. So what does it do? To nullify its positive charge, to eliminate the positive charge, the bonded pair of electrons between carbon and oxygen pull the electron towards itself. So 1 to 2 electron, it will restore its lost pair of electron, lone pair of electron, it restores. So it will come out as water molecule. Oxygen in water molecule has both lone pair of electrons. So from alcohol, OH will pick up H, becomes H2O, and it will come out as water. So what happens when carbon loses its electron? It becomes a carbocation. Carbon carrying plus charge is called as carbocation. So the second step is formation of carbocation. So result of the second step is carbocation. So formation of carbocation is the second step. So from protonated alcohol, when you remove water molecule, oxygen pulls the electron pair, bonded pair of electron towards itself. So the carbon lost its electron to oxygen. Okay, so carbon becomes plus charge. You get carbocation. So carbocation and water is the product. So this is second step is formation of carbocation. Did you understand? This is the second step, formation of carbocation. First step is protonated alcohol. From protonated alcohol, remove water, you get carbocation. Clear? Now the third step. So look at the third step. What are we preparing? From ethanol to ethene. From carbocation, if you remove one hydrogen from the carbon, other carbon, not the carbon which is carrying plus charge, from the other carbon, which has 3 hydrogen, you remove one hydrogen and the electron pair between carbon hydrogen, you bring it between carbon-carbon. So between carbon-carbon double bond, so the carbon lost electron is got back. No, it gets back. Because this electron when comes here, one electron to carbon, the second electron of hydrogen, this carbon will get. So whatever lost electron is got. So between carbon-carbon double bond comes. So valency of carbon is satisfied. And from carbocation, you get ethene just by eliminating a proton. So eliminate the proton. So the proton, first step used a proton, correct? From acid. So the last step, that is produced back. So acid, okay, whatever acid released H plus, that is given back to the reaction mixture. So this will go and attack next molecule of alcohol, next molecule of ethanol. So this goes on until every molecule of ethanol is converted into ethene. So 3 steps. So the last step is formation of ethene by elimination of proton from carbocation. You get ethene. Did you understand? Did you understand, Baburaj? Good evening. Good evening, Baburaj, and welcome to Unacademy's live YouTube class. I hope you understood this. Did you understand? Guys, did you understand, or do you want me to explain again the mechanism? So the first step of the mechanism, remember, you're converting primary alcohol, that is ethanol, to ethene. So the first step is ethanol takes up H plus to give you protonated alcohol. Once protonated alcohol is formed, second step is protonated alcohol lose a molecule of water. So carbon lost its electron to oxygen. So carbon becomes a carbocation. You get a carbocation. Once carbocation is formed, remove hydrogen, eliminate hydrogen as H plus. Proton, it is eliminated as proton. The electron between carbon and hydrogen, that electron will come between carbon and carbon, creating double bond. You get ethene. By elimination of proton, you get ethene in the third step. I hope you understood. So that is dehydration. So alcohol, which alcohol? Primary alcohol, okay, undergo dehydration to give alkene, okay, in the presence of concentrated sulfuric acid at 443 Kelvin. What about secondary and tertiary alcohol? Okay, what about secondary and tertiary alcohol? If it is the secondary alcohol also will give alkene. But look at the reaction condition. Reaction condition is drastically reduced. If it is primary alcohol, okay, which is giving alkene, you have to use concentrated sulfuric acid at 443 Kelvin. If it is secondary alcohol, 85% phosphoric acid is enough. And at 440 Kelvin, 85% phosphoric acid, okay? You need not use concentrated sulfuric acid. You can use milder rehydrating agent. 85% phosphoric acid at 440 Kelvin. If it is tertiary alcohol, even milder, 20% phosphoric acid is enough. And look at the temperature. 358 Kelvin is enough. 20% phosphoric acid at 358 Kelvin will give you alkene. You get alkene. Okay, so reaction condition is drastically reducing. So what do you understand by this? Primary requires drastic condition, concentrated sulfuric acid 443 Kelvin. Secondary alcohol 85% phosphoric acid at 440 Kelvin. Tertiary alcohol only 20% phosphoric acid 358 Kelvin. That means tertiary is more prone to dehydration than secondary than primary. So tertiary undergo readily dehydration than secondary. Secondary alcohol undergo more readily dehydration than primary. So primary least, though, that is why drastic condition is required. So this is the order of reactivity towards dehydration. Tertiary is better than secondary. Secondary is better than primary. This is the order of reactivity. That is what you understand the reaction condition. Okay, now let's go to the secondary alcohol. That is 1, 2, 3. So 2-propanol or propane to all. 3 carbon atoms. So propane, all carbon single bond. So propane, E you remove, at the second carbon atom you have an OH group. So propane to all undergoes dehydration by 85% phosphoric acid at 443 Kelvin. So the second carbon has OH. So one of the carbon, either from the first carbon H will come out or from the third carbon H will come out. Let's say from the third carbon H will come out. So between second and third carbon double bond comes. If what was from the first carbon, that means first and the second carbon double bond would have come. So whichever carbon is losing, so the same carbon will not lose hydrogen. The carbon which is losing OH will not lose hydrogen, even though it has hydrogen. Okay, the carbon to which OH is attached, that carbon will lose OH. Any other carbon which is present next to it, that other carbon will lose H. Between those two carbons, double bond, you get alkene. This is propane. Okay, you have taken 2-propanol, you get propane. Tertiary alcohol, look at this compound. I will take this as my root word. 1, 2, 3, this. Okay, 3 carbon atom. So second carbon atom has a methyl group and second carbon atom has OH group. So it is 2-methyl propane to all. This compound is called as 2-methyl propane to all. Or tertiary, it's carbon. Okay, center carbon in turn attached to 3 other carbon atoms. The carbon to which OH is attached, this carbon is attached to 3 other carbon atoms. So it's a tertiary carbon. So tertiary, altogether 4 carbon atoms. So tertiary butyl alcohol. So it can also be called as, tertiary butyl alcohol. I hope you understood why tertiary butyl alcohol. The carbon to which OH is attached to 3 other carbon atoms like this. So this is a tertiary carbon. Altogether 4 carbon atoms. So tertiary butyl alcohol. Okay, so the carbon to which OH is attached, okay, that will carbon will lose OH. There are 3 CH3 groups. Any one CH3 group will lose H. Between those 2 carbon atoms, okay, double bond, you get alkene. And what is the name of this compound? Okay, 1, 2, 3. So the carbon which is having double bond should be the smallest number. So second carbon has a methyl group. Excuse me. Second carbon has a methyl. This is the substituent. So this compound is 2-methyl prop. Okay, you have a double bond. So you have to write a 1-ene. Okay, 2-methyl prop 1-ene. Okay, this is the name of the compound. See, 1, 2, 3. So the carbon carrying double bond, that should get smallest number. Okay, 1, 2, 3. So 2-methyl prop. Double bond is there. You cannot write now ene. Double bond is at which carbon? First carbon atom. So prop 1-ene. So 2-methyl prop 1-ene or 2-methyl propene also you can write. 2-methyl propene. When you write 2-methyl propene, understood? Ene is at the first carbon atom. Okay, this or this. Any one of the names. I hope you understood. So, 3 classes of alcohols are slightly different. Okay, product is same alkene, but condition can be milder as you go from primary to secondary to tertiary. Tertiary has the mildest dehydrating condition, only 20% phosphoric acid. I hope you understood this. Okay, now let's go to the next reaction, oxidation. Now, what is happening in oxidation? See, if I have to generally represent an alcohol, I will represent it like this. Okay, let me represent like this. Alcohol. Now, in alcohol, when undergoes oxidation, 2 things are happening. Bonds are broken and bonds are formed. A bond is formed between carbon and oxygen. So, between carbon and oxygen, double bond is formed. One bond is already there. Another bond appears. And oxygen-hydrogen bond breaks. Carbon-hydrogen bond breaks. 2 bonds are broken. A bond is formed between carbon and oxygen. So, carbon and oxygen double bond you get. And between oxygen and hydrogen bond is breaking. So, that's why you get C double bond O. The hydrogen bond is broken. Carbon also loses 1 bond with hydrogen. So, you have only 2 bonds. See, only these 2 bonds are there. This is what you get on oxidation. So, on oxidation, between carbon and oxygen double bond appears. Carbon hydrogen bond is broken. Oxygen hydrogen bond is broken. So, you have 2 valencies of carbon with the double bond O. Now, what is these 2 groups depends upon what class of alcohol you are taking. That is, whether it's a primary, a secondary or tertiary. Okay? Yes, that is one thing. Second thing I wanted to know is I hope you understood. I'm writing here again. See, carbon 1 bond, CH bond I'm showing. Okay? And OH. So, between O and H bond is broken. Between C and H bond is broken. And between carbon-carbon on oxidation, carbon-oxygen double bond appears. So, this is it. Okay? And the oxidizing agents can be neutral. What are the oxidizing agents which is used for oxidation of alcohols? Neutral, acidic or alkaline. Potassium permanganate you can use. Okay, it can be neutral potassium permanganate or acidic potassium permanganate or alkaline potassium permanganate or acidic potassium dichromate you can use, K2Cr2O7, or dilute nitric acid, dilute HNO3 you can use, or anhydrous CrO3, chromic anhydride you can use, or PCC. What is PCC? Pyridinium chlorochromate. About this little more information I will give you. Okay, pyridinium chlorochromate I will be discussing in little more detail. Okay, yes, pyridinium chlorochromate is also called as a Corey's reagent. Pyridinium chlorochromate or Corey's reagent. You can use any one of this compound as or reagent as oxidizing agents. Okay, now as I was telling you, depending upon what kind of alcohol you are using, okay, is primary or secondary, tertiary, product will be different. If it is primary alcohol, which is on oxidation, first it forms CH2OH converted into aldehyde, CHO, which undergoes oxidation, further oxidized to give you carboxylic acid. So CH2OH becomes CHO, that is aldehyde. Primary alcoholic group becomes aldehyde group. Aldehyde group further undergoes oxidation to give you carboxylic acid. Now, if you want the reaction to be stopped at aldehyde, then you have to use these these reagents, CrO3 or PCC. If you use any one of above, okay, any one of these, then you get carboxylic acid as the end product because it's a strong reducing agent. If you want the reaction to be stopped at aldehyde, then you have to use CrO3 or PCC. Okay, so if you use KMNO4 or K2Cr2O7 all those will directly convert primary alcohol to aldehyde, then to carboxylic acid. So end product will be carboxylic acid. If you want the reaction to be stopped here, then to cut off the further reaction, you have to use the PCC or CrO3. That is what you have to understand. Okay, so primary alcohol undergoes oxidation with the strong, only with the strong oxidizing agents, primary alcohol, that is another thing. Only with the strong oxidizing agent, okay, primary alcohol undergoes oxidation like alcoholic or alkaline KMnO4 to form aldehyde first, which further undergoes oxidation to give you carboxylic acid. For example, if you take ethanol, CH2, CH3, CH2OH. So CH2OH, this is primary alcohol, is it not? Primary alcohol. In the presence of alkaline KMnO4, Bayer's reagent. What happens to CH2OH? CH2OH becomes COOH. Bayer's reagent is a strong oxidizing agent. So first CH2OH becomes CHO. So you will be getting CH3, CHO, which further oxidized by alkaline KMnO4 into COOH. Now what you have to notice here is how many carbon atom is there in the original alcohol. Same number of carbon atom will be there in the acid. Same number of carbon atom in the aldehyde, same number of carbon atom in the acid. If you have 2 carbon in the original alcohol, the aldehyde will have 2 carbon, carboxylic acid also will have 2 carbon. Same number of carbon atoms. Same number. Okay, I hope you understood. That is about primary alcohol. Okay, now what else? Example, okay, as I was telling you, if you don't want carboxylic acid, you can stop the reaction at aldehydic level. So what you have to use? You have to use reagents like CrO3 or PCC. Okay, so primary alcohol undergoes oxidation in the presence of anhydrous chromium or chromic oxide, or you can also, this is called as chromic oxide, anhydrous chromic oxide, or chromium anhydride. Chromium anhydride. Or chromic anhydride. Chromic anhydride. CrO3. So CH2OH is oxidized by CrO3 into CHO. Again, same number of carbon atoms. How many carbon atoms are there in the primary alcohol? Same number of carbon atoms in the aldehyde group. Same number of carbon atoms. Okay. Now we can also use, instead of CrO3, PCC, pyridinium chlorochromate. Now, what is pyridinium chlorochromate? Let me tell you a little more about this. Now, oxidation of primary alcohol can be stopped. Oxidation of primary alcohol can be stopped at the aldehydic level by using reagents like, first one, Collins reagent. You can use Collins reagent. Now, what is Collins reagent? Okay, Collins reagent is CrO3 with the 2 pyridine. C5H5N. Okay, so this is chromium trioxide and pyridine complex. Chromium trioxide and pyridine complex. That is Collins reagent. You can use Collins reagent. What is Collins reagent? It's a complex of chromium trioxide and pyridine. Or you can use Corey's reagent. Corey's reagent. Or Corey's reagent is also called as PCC. What is PCC? Pyridinium chlorochromate. Pyridinium chlorochromate. What is pyridinium chlorochromate chemical formula? That is the chromium oxide with the C5H5N pyridine and HCl complex. Instead of this, you can also write it as complex, pyridinium chlorochromate as like this: C5H5NH plus with CrO3Cl minus. This is pyridinium chlorochromate complex. Now it's a complex of chromic oxide with the pyridine and HCl, or this is it, C5H5NH plus CrO3Cl minus. So this is Corey's reagent or PCC or pyridinium chlorochromate. Instead of that, you can also use PDC. What is PDC? Pyridinium dichromate. Pyridinium dichromate in anhydrous medium like CH2Cl2. CH2Cl2. Okay, can also be used as an oxidizing agent. All these oxidizing agent will stop oxidation of primary alcohol. Okay, primary alcohol, oxidation of primary alcohol at aldehydic level. Okay, we can use it. Can simply or simple CrO3 can also be used. CrO3 can be used. Okay, look at this. You're using PCC. Okay, what happens? CH2OH. See, whatever you have, this is the entire thing is your R group. Whatever you have as an R group, that is preserved as it is. So you have CH3, CH double bond CH. So CH3, CH double bond CH. That is preserved as such. A primary alcoholic group, CH2OH becomes CHO, aldehyde group, in the presence of PCC or CrO3. So this is what you have to notice. Okay, what you have. Look at the oxidizing agent and decide what you get. Okay, if you had used alkaline KMnO4, it becomes a COH, like that. So if it's primary alcohol, you will get aldehyde or followed by carboxylic acid, depending upon excuse me, what kind of a oxidizing agent you are using. Okay, now what happens to secondary alcohol? Secondary alcohol on oxidation with the CrO3, you will get ketone. Okay, CHOH in the presence of CrO3, secondary alcohol becomes CO. Okay, so what is happening here? Carbon and hydrogen bond is broken, oxygen and hydrogen bond is broken, carbon and oxygen between them, double bond appears. So you get ketone. Now question comes, can we convert ketone into carboxylic acid? RCOOH, can you? Yes, you can. Okay, under ordinary conditions, ketone cannot be converted into carboxylic acid. Further oxidation is difficult, but under drastic conditions, you can further oxidize ketone into carboxylic acid. So secondary alcohol is oxidized into ketone, which in drastic conditions is oxidized to carboxylic acid. Which is the drastic condition? You have to use strong, powerful oxidizing agent like acidified potassium dichromate. Acidified potassium dichromate further oxidizes ketone to carboxylic acid. But what you have to notice here is this. On oxidation of ketone to carboxylic acid, the number of carbon atom will be lesser than the original alcohol. The number of carbon atom becomes less. Number of carbon atom is less. Okay, the number, if you start with 2, it will be end up, if you start with 3 carbon atom, okay, you will end up with 2 carbon atom, like that. See, for example, let me give you an example. Okay, CH3, you have, okay, this is isopropyl alcohol, CH3, CHOH, CH3, okay, can also written as CH3, CHOH, CH3, like this. This is isopropyl alcohol. Okay, isopropyl alcohol, if you use CrO3, you will get acetone. So 3 carbon atom, 1, 2, 3 carbon atom, you get 1, 2, 3 carbon atom ketone if you use CrO3. But that is if you use little less strong oxidizing agent like CrO3 or PCC, if you get secondary alcohol into ketone. But if you use strong oxidizing agent like K2Cr2O7 in an acid medium, H2SO4, okay, what will happen? Dehydration will take place. You will get CH3, C double bond O, CH3. That is, you will get acetone. Acetone is formed, which further undergoes oxidation with the same reagent. Say no potassium acidified potassium dichromate will further oxidize into CH3, COOH. The bond between carbon and CH3, one CH3 breaks here. So this entire group, CH3CO, double bond O becomes CH3COH, and the CH3 is oxidized to carbon dioxide and water. Look at this. You started with 3 carbon atom. Now carboxylic acid only 2 carbon. So less number of carbon atoms. This is what I meant. Okay. So the number of carbon atom is not preserved. So whatever in the original alcohol you have, okay, carboxylic acid produced this in the secondary alcohol. From the secondary alcohol you have carbon less than the original alcohol. Okay. Now this was with the isopropyl alcohol. Now if you take another example, see CH3, CHOH, CH2, CH2, CH3. So the alkyl chain length is different on the other side. Okay. So what happens? Now bond between carbon, oxygen and hydrogen is broken. Between these two double bond comes, is it not? So the first oxidation with the strong oxidizing agent, you get CH3, C double bond O, CH2, CH2, CH3. This is what you get. Okay. So this part CHOH becomes a C double bond OH, which on further oxidation, okay, what will happen? This bond breaks like this. So CH3CO becomes a CH3COOH. So you get acetic acid, and CH2 becomes a CHCOOH. CH2 also becomes COH, and CH2 CH3. So CH3, CH2, CH2 becomes a COH. You get acetic acid and propionic acid. This is acetic acid and this is propionic acid. Okay, 2 types of carboxylic acid you get. 2 types of carboxylic. So as the alkyl chain increases, This is what happens. So double bond C double bond O and carbon bond is broken, and you get two fragments. Both is converted into, see the where with bond breaks. Here CO becomes COH. The CH2 group becomes COH. So you get mixture of carboxylic acid. So if you use stronger oxidizing agents, okay, so that means drastic condition. So secondary alcohol becomes ketone. Ketone undergoes further oxidation to carboxylic acid like this. Okay, so what happens to tertiary? Okay, we will discuss in the next class. The time is up. Okay, what happens to tertiary alcohol on oxidation, and lots many other reactions we'll discuss in the next class. I hope you understood. Do you have any doubt? We can post the questions now. Do you have any doubt? No doubt? Okay, if there is no doubt, we can wind up today's class. Thank you for being wonderful audience students. Just keep studying, keep preparing, okay, and keep attending class. Okay, good evening guys, and be safe.